Right, so here we're going to look at differentiating trig functions that have been raised to a power, and this is a bit trickier than it perhaps first appears. And again, we're going to use the chain rule to prove this, and we should be careful how we write these expressions. Notice that when a trig function is raised to a power, that the power appears after the trig function itself, not after the x. So, for example, it would not be written as that, because that would indicate that actually just the x is being squared, that it's not a squared trig function itself. And what we've got to be mindful of is that tan squared x, or sine squared x, or cos squared x, or whichever trig function we're looking at, this is actually the same as tan x all squared. And we need to treat it like this now that we're in this process of differentiating it. So let's rewrite it. So we're going to rewrite this as y equals the bracket of tan x all squared, which is exactly the same as how it's given to us in the question. We've just rewritten it in a different format. Now when we differentiate this, using the chain rule, when we're differentiating a term that's inside a bracket and has been raised to a power, just remember, we bring that power down to the front, so we get 2, times by the original function to 1 less power. But remember, we also then times by the differential of the bracket as well. So the differential of that bracket, the differential of tan x, is sec squared x. And when we bring all this together, we end up with 2 tan x sec squared x. So there's quite a lot going on there. We're just going to have a look at this applied in a few different ways. Let's look at differentiating y equals sine x. And again, you don't have to do this, but it does help to imagine it being written in this form. And therefore, when we differentiate this dy and dx, we end up with 2 comes down, times by the bracket, which has been lowered down by a power, times by the differential, which is 2 sine x cos x. So, now this one here is actually a trick question. You'll notice that the squared sign is actually outside the bracket there. So what we do here is, this is using one of the methods we've looked at earlier, is we'll actually use the chain rule here, and we'll let u equal 2x plus 3 to the power of 2. Now when we differentiate this, du on dx equals 2 lots of 2x plus 3 times by the differential bracket, which is 2, which is 4 lots of 2x plus 3. That means that y is equal to tan u, and dy on du is equal to sec squared u. And then using the chain rule, if we bring all this together, we end up with dy on dx equals du on dx times by dy on du, which is 4 lots of 2x plus 3 times by sec squared u. And if we simplify all of that there, we can write this as 8x plus 12 sec squared, and replace the u back with the value we stated it at the start, and we end up with the following. Now you notice that the process for that is quite different, and that again comes down to the fact that the power is here, not there, so it's slightly different, and we just need to be careful of that when we're working some of these derivatives out. The last one we're going to look at here is y equals cos squared of 4x. Now you see that the squared term is back after the cos here, so that means we can actually rewrite this as y equals cos of 4x squared, and we're going to differentiate this using the process we looked at before, so dy on dx. We're going to bring the power down to the front of the bracket, so 2 times by cos 4x to the power of 1. Now this is the tricky bit. We've got to times this by the differential of this bracket. Now the differential of this bracket, the differential of cos 4x is actually 4 times by, now cos differentiates to minus sine, so minus sine of 4x. Now just remember that this 4 here appears because when we're differentiating cos 4x, we've got to differentiate cos to negative sine, and we've got also times by the differential of this part here as well. And that's where that 4 appears from. So we've got the 2 comes down, so we've got 2 times by the bracket cos of 4x times by the differential of the bracket, and then if we go ahead and tidy all this up here, we end up with 2 cos 4x times by negative 4 sine 4x which is negative 8 cos 4x sine 4x. And that's a good, there's some good examples for you to have a look over that involve differentiating trig functions that have been raised to a power. And I recommend you try and get your head around this and go and practice a few now.